A linear inequality in one variable is a statement involving two expressions, at least one containing the variable and separated by one of the symbols of inequality, less than, greater than, less than or equal to, greater than or equal to. To solve, you would follow the same steps you were solving a linear equality. The only thing that you need to be aware of is if you multiply or divide by a negative number, the inequality sign will change direction. Once solved, you can express the inequality graphically or in interval notation, depending on whatever's asked of you. But I'll show both anyway. So first, we're going to solve the inequality x over 2 is greater than or equal to 1 minus x over 4. Now, I am no fan of fractions, and I typically like to get rid of them if possible. So when you have fractions, we want to use our LCD to get rid of them. And the LCD between 2 and 4 is going to be 4. So here, I'm going to multiply the entire equation by 4. So I take the denominator 2 and I see how many times it goes into 4, which is going to be 2 times. So it goes into itself once and goes into 4 2 times. So now I'm going to take the numerator x and multiply it by 2, and I'm going to get 2x is greater than or equal to, and now I'm going to do the process again. 1 has no denominator to cancel out, so I'm just going to do 1 times 4, which is going to be 4. And then I'm going to see what I can cancel out here, because this one does have a denominator with x over 4. So 4 is going to go into itself 1 time, and 4 is going to go into 4 1 time. And now I'm going to do 1 times x, which is just going to give me x. So minus x, because of the minus sign that's already here. Now this inequality, far easier to solve than the original one. So I'm going to get all my x's to one side. So I'm going to add x over to both sides. And I'm going to get 3x is greater than or equal to 4. And then I'm going to divide both sides by 3 to get x by itself. And I'm going to move this over here for more space. And I'm going to get x is greater than or equal to 4/3. Don't really like dealing with fractions again, but if that's the end result, then it's okay. So in an interval notation, I see this is a greater than or equal to sign. So that means I'm going to have an answer that is bracket 4/3 because of the equal to sign. And since it's pointing to the right forever, it means it's going to the right forever. So I have an infinity with a parentheses. And then graphically, just put a line, the line in the middle, slap a 4/3 in there. And again, it's going to be a bracket to the right forever. So my answer in inequality notation, interval notation, and graphical notation. Next I have 2x plus 1 divided by 3 is greater than x minus 2 divided by 2. Again, I'm no fan of fractions. I want them gone if I can. So I'm going to multiply everything by the LCD. And the LCD between 3 and 2 is 6. So I'm going to go through my entire inequality and multiply everything by 6. So I see my denominator as a 3. It's going to go into itself 1 time, and it's going to go into a 6 2 times. And so I'm going to distribute the 2 to 2x plus 1. So when I do that, I'm going to get 4x plus 2. And now let's do it again for the next term. How many times does 2 go into 6? Well, 2 will go into itself once and go into 6 3 times. And now I'll distribute the 3 to the x minus 2. And when I do that, I'm going to get 3x minus 6. Now again, I'm going to get all my x's to one side, so I'll subtract 3x over to the left side, which will give me x plus 2 greater than negative 6. And then subtract 2 from both sides, which will cancel out. And again, I'll just move this over for more space. I'm going to get x is greater than negative 8. So here's my answer as an inequality. In interval notation, because it's just strictly greater than, we could say that it is parentheses negative 8 to infinity, because again it is greater than going to the right forever. And graphing it, negative 8 in the middle, because as a parentheses around negative 8, I use a parentheses with a big arrow going to the right. Last, 1/3 times 3x plus 5 is less than 1/6 times x plus 4. Want to clear my fractions, get them out of here. So the LCD between 3 and 6 is going to be 6 again. And now I'm going to multiply the entire inequality by 6. So 3 is going to go into itself once, and 3 is going to go into 6 2 times. So now this 2 is going to distribute to 3x plus 5, but I'm just going to kind of write it out as 2 times 3x plus 5 is less than, and now I'm going to take 6 and see how many times it goes into 6 again. So 6 will go into itself once, and will also go into 6 once. So now I'm going to distribute the 1 to the x plus 4, which is just going to give me x plus 4. So nice and simple, and a much better inequality to work with than the original. So I will now distribute the 2 across and get 6x plus 10 is less than x plus 4. And now I'm going to subtract x over to get all the x's to one side. So 5x plus 10 is less than 4. And then subtract 10 from both sides. Those cancel out. And one more time, just move it on over. 5x is going to be less than negative 6. And then divide by 5 on both sides, which will cancel out. And I'm going to get x is less than negative 6/5. Now make sure I divided into a negative, which is fine. The inequality sign does not need to flip. Only if you divide by a negative does it need to flip. So now I'm going to write my interval notation, and since it's less than, that means it goes to negative infinity forever, and then it goes up to negative 6/5, and since it doesn't have an equal to sign, parentheses. And now I will draw my graph with negative 6/5 in the middle, and since the parentheses go into the left forever, I'm going to use a parentheses with an arrow pointing to the left forever. So again, inequality notation, interval notation, graphical notation.